Another question from Newton's laws of motion, which reads, the rear side of the track is open. The rear side of the track is open, and a box of mass 20 kg is placed on the track 4 meters away from the open end. If the track starts from rest with an acceleration of 2 meters per second squared on a straight road, find the distance the track will travel when the box will fall off from the layer, given the coefficient of friction to be 0.15. Okay, so to handle such a problem, we need to be familiar with some formulas. We need to be familiar with these formulas. Okay. We are supposed to be familiar with these formulas. Okay. What else? They have mentioned something like coefficient of friction. So we can also take note of the formula for friction force, which is given by the coefficient of friction multiplied by the normal force. What else? The general formula for force. Force is equal to mass times acceleration. Yeah, I think with those formulas, we are good to go. Though we will not use all the formulas, yeah, but we'll try to pick some formulas which will work best for us. Yeah, and we should be able to know how to select the correct formulas. Okay, because selecting correct formulas yields correct answers. Amazing. Okay, so now they want us to find the distance. Okay, the distance the track will travel when the box will fall off from the layer. Okay, so for this box to fall, it needs to travel this distance, right? Yes. So when this box is traveling this distance, the track will also be moving. So they want us to find the distance this track will travel when this box was traveling this distance. Meaning that the time it will take the box to travel this distance is the same time the track would have traveled a certain distance which they want us to find. In this case, we are going to relate the box and the track in terms of time. So we need to find the time it will take this box to move this 4 meter and use the same time to find the distance the track would have traveled in that same time. Okay? Yeah, with that, I think we are good to go. Yeah, we are good to start. So what do we want to find? We want to find the time. Amazing. From those 4 formulas, which formula should we use, or formulas? In this case, which formula should we use? For the first one, since this track was starting from rest, meaning that the initial velocity was 0, yes, amazing. But what about for the final velocity? We don't know the final velocity. Okay, at that specific time which we want to find. So we don't know the final velocity, meaning that any formula which has got the final velocity is disqualified. Therefore, so since this disqualified, this disqualified, this disqualified, therefore we use this formula, which is distance is given by ut plus 1 over 2 at squared. But what do we want to find? We want to find the time. Therefore, from this formula, we are going to make time the subject of the formula. How? Remember, this thing started from rest, meaning that the initial velocity is 0. So this part will be equal to 0 because it will be 0 multiplied by time, so which will give us 0. So distance is equal to 1 over 2 at squared. All right. So making t the subject of formula will give, so this by this it will be 2s is equal to 80 squared over a over a. Okay. So this side we have 2s a is equal to t squared. Okay. Get rid of the square root. Yeah, this power 2. So t therefore is equal to the square root of 2s over a. So that is the time. That is how we are going to find the time. Okay. Yeah. So we can start replacing actually. Now we can start replacing. So 2. What is the s? The s is 4 meter. What is the acceleration? We don't know the acceleration. We don't know the acceleration. What? Because this acceleration is for the track when it is moving in this direction. For the box, we don't know the acceleration because friction force was acting on the box. If there was no friction which was acting on the box, then this same acceleration of the track would have been the same acceleration which was pulling the box backward. Because we know that when I've got a system like this, right? When let's say a 20 Newton force is pulling or pushing the car in this direction, there will be an opposite and equal force which will be pulling this box in this direction, right? Yes, the forces will be equal. But now the acceleration will not be equal because there was friction which was reducing the acceleration, right? It was reducing the force and the acceleration actually. So what are we saying now? Okay, we want to find the acceleration of this box when it was moving in this direction, right? Yes. How do we find the acceleration? Okay, we can say what force will be pulling this box in this direction. Okay, so it will be this same force. The same force which will be pulling the car in this direction will be the same force which will be pulling the box in this direction, right? What do we mean by that? We can find the force for the car. The force will be given by the mass in the acceleration, right? But since we've already said to say the force which will be pulling in this direction will be the same one pulling in this direction, okay? And the same force is as a result of this acceleration. Therefore, the force which will be initially pulling the box in this direction will be given by the mass of the same box by the acceleration. So initially the force is 40 Newton. But this 40 Newton was acted upon by friction force, okay, or was reduced by friction force. How? We know how to find friction force. So initially we had this force, right, which was pulling the box, right? Then we had friction force again, which is given by this. So we have been given the coefficient of friction to be that. The normal force for the box, what is the normal force for the box? So the normal force for the box, since it is on a horizontal surface, is equal to the weight. So in this case, the normal force is equal to the weight. What is the weight of the box? The weight of the box is mg, right? So, and this is the normal, right? So what is the mass? The mass is 20. G is gravity. Okay. Yes. So punching gives 29.4 Newton. So this was the friction force, right? So to find the resultant force now, which was producing a certain acceleration, we want to find, we'll say the initial force, that one, which is the 40, minus, in other words, we can just say this force, it was pulling the box in this direction, so we can just say force minus friction force is equal to the net force. Okay, so 40 minus 29.4 is equal to the net force. So 40 minus 29.4 gives 10.6 is equal to the net force. So it is this net force that will produce a certain acceleration. Please take note. The net force is the one that will produce a certain acceleration. In this case, we'll say net force is equal to mass times acceleration. The net force is 10.6. What is the mass for the box? Is 20. So over 20 over 20. Therefore, the acceleration is 10.6 over 20, which will give us 0.53 meter per second squared. So this was the acceleration of the box. This was the acceleration of the what? Of the box. Therefore, as we can see, we can just get this acceleration and depress here, because our interest is finding the time, right? So depress here 0.53. Therefore, our time is 3.885143,449. Time is equal to 3.89 seconds. Are we okay so far? Hope we are fine. Okay, yeah, so just relax. Okay, just relax. We are almost there. Just relax. Okay, great. So from there, let me just clean this part. Yeah, I'll clean this part. So now we want to find the distance this truck will travel in 3.89 seconds. What will be that distance? First of all, we need to find, because this thing started from rest, meaning that at 3.89 it was at a certain velocity. So first of all, we'll start with finding the final velocity at this time, After finding the final velocity at this time, we can now use all the data we have to find the distance this track would have traveled. So what will be the final velocity at this time? The final velocity will be given by what? First of all, let's take note of some things because we are supposed to use all of them. For example, we have got this acceleration. So our formula should have acceleration, okay? Should have initial velocity, right? Should have time, right? What else? Yeah, that's all for now. So which formula qualifies? Which formula qualifies? The formula which qualifies is the first one. So we can therefore say final velocity is equal to initial velocity plus 80. The initial is 0, started from rest. The acceleration of the track, remember, is 2. What is the time? The time is 3.885 in some values. I'm using this one, right? So 2 multiplied by the time gives the velocity to be 7.770286899. 7.77 meter per second, right? Okay. All right. What else? What else do we need? Now we need to find the distance. Which formula qualifies? Let's check which formula qualifies. Let's remember that on our data, we've got acceleration, we've got initial velocity, we've got the final velocity, we have got the time, okay? What else do we have? Yeah, I think this is all what we have. So which formula has got the acceleration, initial velocity, final velocity, and the time? And the distance which we want to find. So in this case, this one doesn't have the distance, disqualified. This one has the distance but doesn't have the acceleration, disqualified. This one has the acceleration, the initial velocity, but doesn't have the final velocity, disqualified. What about for this one? This one has the acceleration, initial velocity, final velocity, but it does not have the time. Therefore, it has been disqualified. If those have been disqualified, then which one are we supposed to use? Which one are we supposed to use? Well, since we have the acceleration, right? So let's now choose between this one and this one. Okay? Let's now choose. Let's choose. So final velocity, initial velocity, time. Okay, so the acceleration was already used. Okay. Therefore, Let's use this formula. Let's use that formula. Okay. The distance is equal to the final velocity, initial time, equal to. So this 3.885143449 over 2 gives the distance to be 15.09433573. This is our distance, right? Yeah, this is our distance. But why didn't we use this formula? Well, that formula doesn't have time. And time in this case was a vital thing. Okay? Time was very important because we had to get time from the box, then relate it to the track. So that one, but you can try it out. Let's give it a try actually. Let's give it a try. Let's give it a try. Yeah, there are different ways of killing a rat, right? Let's give it a try. Okay. Yeah, it's not working. It's not working. Okay, it's not working. What about for the third one? What about for this equation? So this one didn't have time. So yeah, this one doesn't work. It will not work in this case. What about for this one? The first one will also not work. It doesn't have distance. We remained with these two, which we said, no, this one disqualified, this one disqualified, this one what, but this one has qualified. What about for this one? So it has got initial velocity, it has got time, okay, which is a very vital thing, but it doesn't have the final velocity. It doesn't have the final velocity at that time. It has time, but it doesn't have the final velocity at that time. So will this formula work? Well, let's try it out. So I've got the initial, okay, so acceleration, time, multiplied by the acceleration. Okay. Well, this formula also works. So this formula also yields the same answer. Therefore, this is the solution. Therefore, this is the solution. But remember, there are different ways of killing a rat. Some people can use a gun, some can use a catapult, some can just use a stone, but it's up to you to choose which way you are good with, which way you are comfortable with, okay, which way you understand better. Otherwise, thank you so much for watching. Thank you so much. Really appreciate.